Our lesson today is to be able to subtract rational numbers. When we subtract rational numbers, we want to use the same rules that we used when we subtracted integers. And when we subtracted integers, we used rules for integer addition, but we also used the additive inverse. So we want to apply the same principles using the additive inverse, using the rules for addition when we subtract integers. So the key idea is as follows. Here we have the example 2/5 take away -1/5. Right? When we see subtraction, we want to use the additive inverse, which means we want to add the opposite. When we add the opposite, we have to do two things. We have to change the subtraction sign to an addition sign, and then we change the sign of the number that follows to its opposite. This was a -1/5, so we make it positive. We essentially change the subtraction problem to an addition problem. So this subtraction problem is now the same as this addition problem. And once we have the addition problem, we do the addition problem the same way we've been doing all of our other addition problems. Common denominator, add or subtract the numerators, and we have our answer. All right? So let's take a look at our first example. We have -4 1/7, and we want to take away -6/7. First thing we want to do is to use that additive inverse. When I use the additive inverse, we must do two things. We add the opposite. We change the subtraction sign to an addition sign, and we change the number that follows to its opposite. We now have the following addition problem. -4 1/7 plus 6/7. Once we have the addition problem, the next step is to change everything to a fraction. This mixed number has to be changed to a fraction. And we do that by multiplying the denominator times the whole number, and then we add the numerator. 7 times 4 is 28, plus 1 is 29. So we have 29 over 7, but that is negative. And then we're going to add the 6/7. The next step is to look at the denominators. We cannot add or subtract fractions without the denominators being the same. And I see that the denominators are the same here. So once the denominators are the same, we want to rewrite the numerator with the common denominator. My numerator is going to be -29 plus that +6. And now we use our rules for addition of integers. -29 plus 6. We subtract their absolute values, and there's more negative than positive. So that's going to be -23. That's going to be over 7. And then I want to simplify that fraction, rewrite it as a mixed number. 7 goes into 23 three times. 3 times 7 is 21. We have 2 left over the 7, and that has to be negative. So -3 2/7 would be our answer there. All right? Let's try the next one. When we're subtracting rational numbers, that includes decimals. We have the problem 12 8/10 take away 21 6/10. Right away we want to use the additive inverse, so I want to change the subtraction sign to an addition sign, change the sign of the number that follows to its opposite. So we now have 12 8/10 plus -21 6/10. Now we're adding opposites, and when we're adding opposites, we have to subtract their absolute values. So that's going to be 21 6/10 minus the 12 8/10. But because there's more negative than there are positive, that difference is going to be negative, so I'm going to make sure that I write my answer as negative. All right, now we subtract. I can't subtract 8 from 6, so I borrow from the 1, rename it as 0. That 6 becomes 16. 16 take away 8 is going to be 8. Decimal point. Can't subtract 2 from 0, so I borrow from the 2, rename it a 1. That 0 becomes a 10. 10 take away 2 is going to be 8. All right, and -8 8/10 is going to be our answer. All right, let's try each of these examples here. All right, so we have problem number 1. All right, first we write the problem. 1/3 minus -1/3. Then we use the additive inverse. So we add the opposite. Then we see if the denominators are the same or not. Here the denominators are the same. So I can rewrite with a common denominator, and my numerator is going to be 1 plus 1. 1 plus 1 in the numerator. I add my numerators. 1 plus 1 gives me 2. The denominator is going to be 3. So problem number 1 would be 2/3. Okay. Problem number 2. Copy the problem. Negative 3 1/3 minus 5/6. First step, use the additive inverse, so we add its opposite. Next step, write everything as a fraction. 3 times 3 is 9, plus 1 is 10. So that's 10 over 3, but because the negative 3 1/3 is negative, that improper fraction has to be negative as well. And then I recopy the negative 5/6. Now I have to recognize that I do not have fractions with a common denominator. And if we want to add or subtract fractions, we have to have the denominators the same. So I look for the least common multiple of the denominators, which are 3 and 6. The least common multiple for 3 and 6 is going to be 6. So that means each of my new fractions have to have a denominator of 6. Well, that means the negative 5/6 doesn't change, because if I don't have to change the denominators, the numerators don't change. But here, the second fraction, we had to go from an original denominator of 3 to a new denominator of 6. That means we had to multiply by 2 to go from 3 to 6. If I have to multiply the denominator by 2 to make an equivalent fraction, we have to multiply the numerator by 2. So negative 10 times 2 is going to be negative 20. Now we have two fractions with the same denominator. So I write my new fraction over one denominator, and I write my negative 20 plus my negative 5 in the numerator. I take this numerator here, take this numerator here, and we're adding. Well, what is negative 20 and negative 5? Well, when we're adding integers with the same sign, we have to add their absolute values. So that's going to be negative 25 over 6, and that simplifies to what? 6 goes into 25 4 times, because 4 times 6 is 24. We have 1 left over the 6, and because it was negative, right, my mixed number has to be negative. So negative 4 and 1/6 would be our answer for problem 2. All right, let's look at problem 3. First, I want to recopy it. All right, so when I recopy problem 3, that's going to look like this. Right? Problem 3 says we have 4 1/2, and I want to take away 5 1/4. Right? First step, use the additive inverse, add the opposite. So this now becomes the addition problem, 4 1/2 plus negative 5 1/4. Next step is to write everything as a fraction. 2 times 4 is 8, plus 1 is 9. It's going to be 9 over 2, plus 5 times 4 is 20, plus 1 is 21. So it's negative 21 over 4. And the reason why that fraction is negative is because that mixed number was negative. Now we need to rewrite the fractions using a common denominator. My common denominator here is going to be 4. So we're going to have to make new equal fractions with denominators of 4. Right? The second fraction doesn't change. If the denominator doesn't change, then the numerator doesn't change. So we have negative 21 over 4 as my second fraction. My first fraction, to go from 2 to 4, we had to multiply by 2. So I have to use that same factor to multiply the numerator. 9 times 2 is 18. So now we have 18 over 4 plus negative 21 over 4. My next step is to write over a denominator of 4. We have 18 plus the negative 21. I'm adding, I'm adding opposite signs, so we have to subtract their absolute values. 21 take away 18 is 3, but there's more negative than positive, so that's going to be negative 3 over 4. Alright? So keep in mind the steps when we're subtracting rational numbers. First, we use the additive inverse and we add the opposite. Second, we make everything into a fraction if they're not already fractions. Third, we have to rewrite the fractions with a common denominator if the denominators are not the same. Then we make equivalent fractions. We put the fractions over one denominator. We add the numerators and we simplify. All right. Well, let's take a look next at problems 4, 5, and 6. It's a little bit different when we have decimals instead of the fractions. All right. So I'm just going to go to a new sheet of paper here, right, just so that I have some, better space. And let's do problem number 4. I have negative 8 and 4/10, and I want to take away negative 6/10. First step, use the additive inverse. So now I've changed the subtraction problem to an addition problem. I now have negative 8 and 4/10 plus negative 6 and 7/10. I use my rules for integers. And my rules for integers say if I'm adding integers with the same sign, I have to add their absolute values. That means 8 and 4/10, 6 and 7/10. I have to add their absolute values, which means they're both going to be positive when we add their absolute values, but I have to keep the same sign, and because they were negative, I know that my answer is going to be negative. 7 plus 4 is 11, 1 carry the 1, 8 and 6 is 14, plus the 1 is 15, right? Decimal point, negative 15.1 is our answer. Problem 5, negative 20 and 5/10, and I want to take away negative 20 and 5/10. First step, use the additive inverse. We have the opposite. And here you'd want to recognize now that you're adding opposites. Negative 20 and 5/10 plus 20 and 5/10, right? That's going to be 0. So that's one we could do in our head. This last one here, negative 41/100 minus negative 7/100. Add the opposite using the additive inverse. Now I have the addition problem of 41/100 plus 7/100. So I'm going to set that up. 41/100 plus 7/100. We add 1 and 7 is 8, 4 and 0 is 4, decimal point, and we have 48/100 would be the sum. All right. Next page. The distance between any two numbers on a number line is the absolute value of the distance of the numbers. So we want to find the distances between the two numbers on the number line, and to do that, we first find the difference of the numbers. So to find the distance between these two values, I have to subtract 2 1/3 from negative 2 2/3. And that's what we set up here. First step, use the additive inverse. Got to add the opposite. Now I have the addition problem of negative 2 and 2/3 plus negative 2 and 1/3. Next step, write everything as a fraction. 3 times 2 is 6, plus 2 is 8. So that's negative 8/3. Plus 3 times 2 is 6, plus 1 is 7. Negative 7/3. Now what makes this nice is that the denominators are already the same. So because the denominators are already the same, I don't have to make new equivalent fractions. Right? So my next step, I write over the same denominator, which is 3. We have negative 8 plus the negative 7. I'm adding integers with the same sign, so we add their absolute values. 8 plus 7 is 15. Keep the same sign, but that's over 3. And what is negative 15 divided by 3? Right? That's going to be negative 5 as our answer. All right? Next page. All right? And I think this is the last example. I just want to double check. Yes, it is. In our last example, it says, in the water, the bottom of a boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above it. Towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Can the boat and the trailer pass under the bridge? Step number 1, we need to find the height of the boat. And, I tried to draw a little picture for my students. So if here's the water, right, and here's our boat, right, here's our boat, we have, let's see, 2.1 feet below the water. So from here to here, right? That space in there, that's 2.1 feet below the water. And then we have 8.7 feet above the water. So that's here to here, right? That's 8.7 feet. So to find the height of the boat, we're going to have to actually take the 8.7 feet, right? And we want to take away the negative 2.1. Now why is it negative 2.1? Because it's below sea level. So I'm going to write 8.7 minus the negative 2.1. When we add its opposite, that becomes 8.7 plus 2.1. I'll do that over here on the side. 8.7, 2.1, that's going to be 8. 8 and 2 is 10. So we get 10.8 feet is the height of the boat. Step 2, to find the height of the boat and the trailer. Well, the trailer is 1.3 feet above the ground. So if I have that boat on the trailer, it would be the 10.8 height of the boat feet plus the 1.3 the height of the trailer. We add that together, 1 plus 1, right? We wind up with 12.1 feet. And then I look at this drawing here and I see that this is 11 feet 8 inches, which is definitely less than 12.1 feet. So the answer to that question would be no. No. Right? Could the boat pass under there? It could not. All right, so just remember, when we're subtracting rational numbers, we want to use the additive inverse first, then we want to make everything into fractions, then we want to rewrite the fractions with a common denominator. Once we've done that, we add or subtract the numerators, and then we simplify. All right, hope that was helpful. See you soon.